Okay, problem 8.8. Prove that this function, that's defined piecewise, is differentiable at x equals 0 by calculating f prime from the definition. Okay, so first of all, we should actually calculate, make sure that this function is continuous, right? So let's compute the limit when x goes to 0 of f, right? So it's the limit of this function. The limit when x goes to 0, 1 over x minus 1 over e to the x minus 1. Or in other words, the limit when x goes to 0 of e to the x minus 1 minus x, all of this divided by x times e to the x minus 1. Right? Now we know that e to the x is 1 plus x squared over 2 plus small o of x squared, right? We substitute it here, we have the limit when x goes to 0 of, and then we have e to the x minus 1, so 1 goes away, minus x goes away, we have x squared over 2 plus small o of x squared, divided by x times e to the x minus 1, which is x, so you have x squared plus small o of x squared. If you do this, the result is 1/2, so that's good. The function is actually continuous. Okay, now let's see if the function is differentiable. Compute the limit at x of f minus f at 0, which is 1/2, divided by x. So what you have is the limit when x goes to 0 of, and again we have 1 over x minus 1 over e to the x minus 1 minus 1/2, all of this divided by x, and we can try to take everything in the same denominator. You have 2x times e to the x minus 1, and then you have here it's 2 e to the x minus 1 minus 2x minus x times e to the x minus 1, if I'm making this correctly, and then we have x, right? So we can simplify this. This is the limit when x goes to 0, and you have 2 to the x minus 2 minus 2x minus x e to the x minus 1. Okay, and then you have 2x squared e to the x minus 1. Now we know e to the x minus 1 is going to be approximately equal to x, so the denominator is going to be on the order of x cubed. So we want to approximate e to the x up to x cubed, right? So this is like this plus small o of x cubed, right? Let's write it here. So then we have the limit when x goes to 0, and then we have 2 e to the x, so then 2 minus 2 goes away, minus 2x plus 2x goes away, and then so we have x squared over 2 plus 2 times this, so this is x squared, and then plus x cubed over 3, because this is 2 times x squared over 6, plus small o of x cubed, and then you have minus e to the x minus 1, which is x, so minus x squared, and then we have minus x cubed over 2 minus, and then everything else is small o of x cubed. Okay, then divided by, as I said, 2x cubed plus, and everything else is small o of x cubed, right? So then here we have x squared and x squared go away. You have 1/3 minus 1/2 is the limit. Minus 1/3 minus 1/2 is minus 1/6 of x cubed plus small o of x cubed, divided by 2x cubed plus small o of x cubed. This is minus 1 over 12.